Hello and welcome to the section 3.3 video lecture on the theory of equations. We're going to talk about the N Root Theorem today and the Conjugate pairs theorem. Notice there are more rules and theorems in this section, noticeably the theorem of bounds and Descartes' rule of signs. Because of time constraints and moving to this online format, I decided we'll go and skip those. They're not things you need to know, especially with today's available technology. So we're just going to stick to these first two theorems that are more important moving forward. So the first thing here is a definition. So if the factor x minus c occurs k times in a complete factorization of the polynomial p of x, then c is called a root of p of x with multiplicity of k. So this is the idea of factors showing up multiple times. So like to give you an example of this, let's say my polynomial factored as x squared times x plus 2 cubed times x minus 3. Then there are three factors here. So the factors are x plus 2, and x minus 3. And notice how x shows up twice because it's squared, and x plus 2 shows up 3 times because it's cubed. So that means that the multiplicities of those factors, of the roots that goes with those factors, would be 2, 3, and 1 respectively, because that's the number of times the factors show up in the polynomial. So along with this goes the N Root Theorem, which says if p of x equals 0 is a polynomial equation with real or complex coefficients and positive degree n, then when multiplicity is considered, p of x equals 0 has n roots. And remember, the word roots is just another word for solutions. So as we go through this, let's go ahead and look at some problems that have multiplicities going on. And it says, state the degree of each polynomial equation, find all of the real and imaginary roots of each equation, and state the multiplicity when it is greater than 1. And we'll just go ahead and state it for all of them, but really we'd only need to do it when it's greater than 1. So the degree of this first polynomial is 6, because it's the highest exponent in the polynomial. So that means that when we take multiplicity into account, we should expect this polynomial to have 6 roots. Okay, so we can go ahead and try and solve this equation by factoring. So factor out an x to the 4th power. And that leaves us x squared plus 1 equals 0. And now we can take those factors and set them both equal to 0. So now if you look at these factors, you should be able to tell me how many roots you think should come for each one. So from this one, this root over here has a degree of 4, and this one has a degree of 2. So we should expect 4 roots to come from the left-hand side and 2 roots to come from over here. So if we solve this left-hand one, x to the 4th equals 0, we would take the 4th root of both sides, so x equals 0. So we ended up with 1 root. So that means I should have gotten 4, but I only got 1. 4 divided by 1 is 4, so the multiplicity of this 1 root is 4. Now over here, we subtract 1 from both sides, so we get x squared equals negative 1. And then we use the square root property to get x equals plus or minus the square root of negative 1. So x equals plus or minus I. So we got x equals I, or x equals the opposite of I. And so here we expected to get 2 roots because the degree was 2. We got 2. 2 divided by 2 is 1. So each one of these roots has a multiplicity of 1. Okay, and that's the idea. Now on this second one here, the degree is a little harder to figure out because I already have it factored for you to save some time. But if I were to multiply this out, I'd get an x squared squared here, right? So we get x squared squared, so that's x to the 4th. And over here I'd get an x to the 4th, right? Because this is x to the 1st power right now, to the 4th power, so that's x to the 4th. And if you add those together, it's x to the 8th power. So this has a degree of 8. Okay? And each one of these, this side had a degree of 4, and this side has a degree of 4. So we should expect 4 roots from each. So let's go ahead and we've got two factors, so we can set them both equal to 0. So we've got 2x squared plus x squared equals 0, and 3x minus 1 to the fourth equals 0. And we can solve each of those. So start by taking the square root of both sides. So we get x squared plus x equals 0. Then we can factor out an x. So x times 2x plus 1 equals 0. Set those both equal to 0. And solve. So x equals 0 is one solution. Subtract 1. So 2x equals negative 1. Divide by 2. So x equals negative 1/2. And notice over here, I should have had 4 because the degree of this factor was 4. I only got 2 roots. 4 divided by 2 is 2. So each of these has a multiplicity of 2. And notice that matches up with the exponent that we're taking the whole factor by. Okay, over here we should expect 4 roots. So we take the fourth root of both sides, so 3x minus 1 equals 0. Add 1 to both sides, and we get 3x equals 1. Divide both sides by 3, and we get x equals 1/3. We should have gotten 4 roots. We only got 1 root. 4 divided by 1 is 4, so the multiplicity of this root is 4. And notice if you add up the multiplicities, you get the original degree. So 4 plus 2 plus 2 is 8. 1 plus 1 plus 4 is 6 over in the first problem. Okay. So at this point, go ahead and pause the video for a second and try these other two on your own. And when you play it again, we'll go through them. Okay. So now if we go ahead and solve this one, start by factoring out an x cubed. Well, first of all, we state the degree is 5, right? Because the highest exponent is 5. Then we can factor out an x to the third. That leaves me with x squared minus 6x plus 9 equals 0. Set both factors equal to 0. The one on the left, take the cube root of both sides and we get x equals 0. And that was x cubed, so this one root will have a multiplicity of 3. And over here, we can factor this. So two numbers that multiply together to get 9 and add to get negative 6. So we're looking at 9 here. So that would either be negative 1 plus negative 9, which is negative 10, or negative 3 plus negative 3, which is negative 6. So it's that one. So this factors is x minus 3 times x minus 3 equals 0. So we got the same factor twice. That's the definition of multiplicity. So the multiplicity of this root should end up being 2, because we have 2 of the same thing. So if I set one of those equal to 0 and solve, I get 3 with a multiplicity of 2. Notice I didn't solve it twice because I'm going to get the same result for each one, but it shows up twice, so it gets a multiplicity of 2. Okay, and then the last one over here, start by factoring out an opposite of x. So that leaves me with x squared minus 8x plus 14 equals 0. Set those all equal to 0. Divide this one by negative 1. We get x equals 0. Now that was x to the first power, so that's a multiplicity of 1. Over here we can factor this one. So numbers that multiply together give 14 are, or we can try and factor it, but I don't think we're going to be able to. So let's just go ahead and use the quadratic formula. So that's x equals 8 plus or minus the square root of negative 8 squared minus 4 times 1 times 14 all over 2 times 1. So it's x equals 8 plus or minus 64 minus 4 times 14. I think is negative 2. That's 8. Sorry. Yeah. So square root of 8 over 2. So x equals 8 plus or minus 2 root 2, because there's a factor of 4 and 8. The square root of 4 is 2 over 2. And then divide, so we get x equals 4 plus or minus root 2 when we divide both pieces by 2. So that gives us two different answers, x equals 4 plus root 2 and x equals 4 minus root 2. And notice, now we've got three roots. The degree of this polynomial, which, sorry, I forgot to write at the beginning, is 3. So that means each one of these Okay, so now let's go ahead and talk about the second theorem that we're going to look at today, which is the conjugate pairs theorem. And so the conjugate pairs theorem says that if you have a polynomial equation with real coefficients and a complex number a plus bi is a root, then a minus bi must also be a root. So imaginary numbers come in pairs when you're looking at this. So, and the reason for that is when you multiply imaginary numbers together, you get a real number. So let's make sure we all know how to do that part up here at the top first. So one of the things that is important to know about imaginary numbers is that remember that I equals the square root of negative 1 and I squared equals negative 1. Okay, and that's going to be important when we move through these. So if I have roots like 3i and 3 minus I need to add in, because they're imaginary, I have to add in their conjugate pair. So the conjugate pair for 3i is negative 3i, and the conjugate pair for 3 minus I is 3 plus I. So to find the conjugate, you simply change the sign on the imaginary part of the term. So in this case, the imaginary part of the term for 3i is the whole thing, so it becomes negative 3i. For the second one, the minus I is what's imaginary, so that becomes positive. Now, those now are all roots. So we've got x equals 3i, x equals negative 3i, x equals 3 minus I, and x equals 3 plus I. And we're kind of working backwards to try and find the polynomial equation that these came from. So the step before this would have been that something equals 0, right? If we look back at one of these equations we just solved, right before we have the roots, what we add is we add all the factors equal to 0. So go ahead and set one side of the equation for each of these equal to 0. So for the first one, we subtract 3i from both sides. So that gives me x minus 3i equals 0. Here I add 3i to both sides. So that's x plus 3i equals 0. Here I need to subtract 3 and add I. So that's x minus 3 plus I equals 0. And the last one, we need to subtract 3 and subtract I. So that's x minus 3 minus I equals 0. And then right before that, all the factors were multiplied together. So this is x minus 3i times x plus 3i times x minus 3 plus I times x minus 3 minus I equals 0. And so now to find the polynomial these come from, I just need to multiply these all out. So we can use our box method. I'm going to multiply the two on the left together. So we've got x and negative 3i, x and positive 3i. So x times x is x squared, x times negative 3i is negative 3xi, x times 3i is 3xi, and 3i times negative 3i is negative 9i squared. And now we can simplify that. So 3xi and negative 3xi cancel. So that leaves us with x squared, and I squared is negative 1. So negative 1 times negative 9 is positive 9. So this will be x squared plus 9. Okay, and then we multiply these two together. So once again, I can use the box. So I'll draw my box. So I've got x, negative 3, and I. X, whoops, I didn't draw a big enough box, so let's try that one more time. Okay. So x, negative 3, and I. X, negative 3, and negative I. So x times x is x squared. X times negative 3 is negative 3x. X times I is xi. X times negative 3 is negative 3x. Negative 3 times negative 3 is 9. Negative 3 times I is negative 3i. X times I, negative I is negative xi. Negative 3 times negative I is 3i. And negative I times I is negative I squared. So negative 3i and 3i cancel, negative xi and xi cancel, and then we combine like terms for the rest of these. So we've got x squared, we've got negative 3x and negative 3x, so that's negative 6x, and then we've got 9 and negative I squared. Well, I squared is negative 1, so negative I squared is positive 1, right? Because it's negative I squared is negative 1, which is positive 1. So 9 plus 1 is 10. And now we just multiply these two polynomials together to get our final answer. So I'll draw another box over here. This one's 2 by 3. So we've got x squared and 9 on that side, and x squared, negative 6x and 10 up here. X squared times x squared is x to the fourth. X squared times negative 6x is negative 6x cubed. X squared times 10 is 10x squared. 9 times x squared is 9x squared. 9 times negative 6x is negative 54x. 9 times 10 is 90. And now we combine like terms to get our final answer. So that's x to the fourth minus 6x cubed plus 19x squared minus 54x plus 90 equals 0. And so there's a polynomial that has the two roots we were originally given with real coefficients. Okay, so that's the idea. So you find the conjugates of any imaginary terms, and then you multiply everything out to get the original polynomial. So if we try the bottom one here together, start out by finding the conjugates. So 5 doesn't have a conjugate because you changed the sign on the imaginary part. 5 doesn't have an imaginary part, so it's just 5. But 4 minus 3i does. It's 4 plus 3i. So we'd have x equals 5, x equals 4 minus 3i, x equals 4 plus 3i. Subtract 5 from both sides to get x minus 5 equals 0. Subtract 4 and add 3i to both sides to get x minus 4 plus 3i equals 0. And last, subtract 4 and subtract 3i to get x minus 4 minus 3i equals 0, and then multiply those together. And when you're multiplying them together, notice in the first one, I started out by multiplying the conjugates together first. And that was on purpose because that made the i's go away. So that's what we want to do here. We want to start out over here by multiplying the conjugates together. So x negative 4, 3i, x negative 4, negative 3i. X times x is x squared. X times negative 4 is negative 4x. X times 3i is 3xi. Negative 4 times x is negative 4x. Negative 4 times negative 4 is 16. Negative 4 times negative 3i is negative 12i. X times negative 3i is negative 3xi. Negative 3i times 4, negative 4 is 12i. Negative 3i times 3i is negative 9i squared. So we've got x minus 5 already, and now we multiply that by when we combine like terms here. So the negative 3xi and positive 3xi cancel, 12i and negative 12i cancel. So we get x squared minus 4x is minus 8x, and 16 minus 9i squared, well, I squared is negative 1. So that makes this a positive 9. 16 plus 9 is 25. Equals 0. And now we multiply these two together. So that's a 2 by 3. So we've got x and negative 5 and x squared, negative 8x and 25. And multiply these together. So x times x squared is x cubed. X times negative 8x negative 8x is negative 8x squared. X times 25 is 25x. Negative 5 times x squared is negative 5x squared. Negative 5 times negative 8x is 40x. And negative 5 times 25 is negative 125. Combine like terms and we get the final answer. So x cubed, negative 8x squared minus 5x squared is negative 13x squared. 40x plus 25x is 65x minus 125 equals 0. And so there's the original polynomial equation that would give us the two roots we were given. Okay, so go ahead and pause the video for a second and try these other two here. And then when you restart the video, we'll go through them together. Okay, so here we go. So if we have 4 plus I as a root, we need its conjugate as well. So that's 4 minus I. So we've got x equals 4 plus I and x equals 4 minus I. Set one side equal to 0 and you get x minus 4 minus I equals 0 and x minus 4 plus I equals 0. So now we want to multiply those two factors together. So x minus 4 minus I times x minus 4 plus I equals 0. And now you can use the box method if you want to multiply those together. So x negative 4 negative I, x negative 4 positive I. X times x is x squared. X times negative 4 is negative 4x. X times I is negative xi. Negative 4 times x is negative 4x. Negative 4 times negative 4 is 16. Negative 4 times I is 4i. X times I is xi. I times negative 4 is negative 4i. And I times negative I is negative I squared. Xi and negative xi cancel. Negative 4i and 4i cancel. And so now we get x squared minus 4x, which is negative 8x. And 16 minus I squared is 17. Because negative I squared is positive 1, as we showed with the problem over here on the right. And then for the last one, I have 4 is fine. I have negative I, so its conjugate is positive I. So that means I've got x equals 4, x equals the opposite of I, and x equals I. Set one side equal to 0, and you get x minus 4 equals 0, x plus I equals 0, and x minus I equals 0. So this is x minus 4 times x plus I times x minus I equals 0. And now do the multiplication. So start with the conjugates. So xi and x negative I. X times x is x squared. X times I is xi. X times negative I is negative x times I is negative I squared. Negative xi and positive xi cancel out, and negative I squared is 1. So this is x minus 4 times x plus 1, x squared plus 1 equals 0. And now multiply those together. Okay, so that's x negative 4 and x squared and positive 1. X times x squared is x cubed. X squared times negative 4 is negative 4x squared. 1 times x is x, and 1 times negative 4 is negative 4. So we get x cubed minus 4x squared plus x minus 4 equals 0. Okay, and that's